Welcome to the Keep It Simple Astronomy channel live. Today we will work, or better saying, we will have fun with my 12-inch Dobsonian. Finally, it's not so windy today. Hello, Quasar! So I want to catch again the COMET C-2017 PANSTARRS, but now with my 12-inch Dobsonian, and it will be the first time I will capture it with this bigger aperture. It will be fun. Good morning, Steven. Boa noite, Fernando. Roque, Portugal. So, we have a bit of wind, but it's not a problem, at least for now. We still have the moon, as you know, and I wanted to do it now because I may miss the opportunity if the moon... It's getting worse now. Tomorrow it will be worse and the moon will be more brighter and higher in the sky. So now I will connect. I will show you, just for the people that don't know, I will show you the telescope I'm using today to have fun with you. Hold on. Is this. So the 12-inch over an equatorial platform is exactly like this outside. We still have today a bit of haze here from the ocean, but I will be pointing up to the comet, so no problem. Yesterday I had a great night. It was better than today because it was no wind, and pointing up it was marvelous. I show you the... I post the Iris Nebula, which is a nebula that with a LED light in the street I couldn't catch very well, and now I can. I was so excited with it. Now, let's connect the platform. First, open Stellarium to see where is the comet. Boris is God. Well, that we don't know. Nice name. Do you have any tips for Dobsonian astrophotography for someone who is tracked but doesn't have an equatorial platform? If he's tracked, if you mean by tracked, you have a go-to, your Dobsonian has tracking. So yes, all the tips. Keep coming to my live streams. Watch very well what I'm going to do now. I don't know the size of your Dobsonian. It's a bit different with this beast I have outside rather than 2 days ago with the 8-inch. It's much more easy to manage. Greetings for Arizona. Love it, Arizona. Don't feel sorry for that. It's funny. Well, I will connect the platform. No, first I have to open Stellarium. This is so fast with the Dobsonian. Incredible. I place it outside before dinner and it's like that. Always collimated. Let's see where the comet is. Let's open here. It's very versatile, very funny to have the Dobsonian imaging with the Dobsonian. Okay, Control 1. To point the pointer. This is a push-to system for the people that don't know. It's a push-to system, a free one that you can also use when you have a tracked Dobsonian. You just have to watch my video. It's down at the description, the link. Watch careful and later, and you can do the same as I'm doing now. Control 1 to the pointer to the comet, which is the object we will going to capture. Let me see where the moon is. Should be... yes, it's here, you see? The moon now is getting down here. It will not mess too much. It's a bit bright, the sky, but we still can do something. Beautiful. So I have to place the... I think I can see Ophiuchus constellation. So I will try to find this star and this one here, up, making the triangle. This is how I do for visual and also for imaging. Then with imaging I will have the help, of course, of the push-to system, the free push-to I have. So I will find this one, and this makes more or less a square here. Makes more or less a square. And if I place the Telrad a bit down and to the left of the square, it will be my reference. So now I will open SharpCap. First I will have to check the focus, of course. We will point to a nearby star, a bright one. So sequencer. One of these days, if someone wants to struggle with a sequencer, and I can do it live here. Just let me tell you something about the sequencer. This is the best tool. Look, I click on a button and it opens the camera to 94. It placed me already with the gain and the exposure I want. You just have to do one thing. Listen carefully. You just have to do one thing. If you already do live stacking, it doesn't matter if you are very good at it. If you do something with SharpCap, you will notice that some things that you do are like a routine. You do always the same thing. If I didn't use the sequencer now, I will open the camera, I will adjust the gain for the gain that I want, blah blah blah. All those things that you always do, you point on the paper. 1. Open the camera, camera X. 2. Adjust the gain, 2. Number of the gain. 3. Adjust the exposure to X seconds. Usually I start with 2 seconds. This is 2 seconds to be better. Etc. etc. You make a list of all those things and bring the list to a live stream or copy that list to the chat, and I do, or send me by email if you want, and I do you the sequence here for you to use, and I send to you, and I explain how to do it for you to learn to do. If you do one, you will do all the rest. It's very, very powerful, very powerful. You see, I don't have to do nothing. Now, let's connect the platform for these stars to stop. Start hopping. You see, the image tells me that the thing is not very, it's a bit grainy. I put it to the side, I think it's focusing. Yes, it's still on focus. I will not touch it. Let me zoom a bit. Yes, it is. The Newtonians, in this case the Dobsonian, we don't really need the Batinov mast. I don't feel the need of it. It helps, but it's an hassle to have it around. And it's faster like this. Now, let's point to the object. Should be more or less there. Now I forgot to do the trick here for this object is important, which is, I repeat again, to click on this thunderbolt in this mini histogram in the right, at the right. When I click it, it will mess the image, but it will boost everything, you see? Now as it's the moon, when it's the moon, this mess much more, and we slide this bar here to the right a bit. We just want barely see the stars, because this is pushing so hard that when the comet or other object, a galaxy or something, appears, usually we can't see them, those kind of objects like this comet, but like this it will pop on the screen. You will see now. Plate solve. Now I'm plate solving to see where the object is. Sharp cap is plate solving and will tell me where is the object. In Stellarium, that free push to system I use. Let's wait a bit. When the bar gets green, turns green, here at the top, it's yellow, it's solving. Taking time. Okay, green. Let's see, I'm here, I'm very close to the comet. Look, the comet is here. I will change, as I usually do, to get a better feeling. I will change the tail rod here at the top of Stellarium for my camera. I will just have to change the telescope with a Nexus. I'm using the Nexus, Arizona Nexus, which is a focal reducer with coma corrector. It's a brilliant tool, better than expected. And my telescope is pointing here, is where I point the telescope. I will move to the right and down, it's near the target. You will see now the comet. I will explain why I was struggling with a 12-inch source to center it. I didn't want to center exactly the comet because I know we have the tail here, so I will use only this square. It's another trick that I use to have more brightness and sharpness and magnification with the stars on the nexus. And I didn't want to center, but it's almost at center. Let's see how it works. Nexus. Nexus. Hold on. It's 4 seconds with the trick. Okay. I don't have the dark prepared. Okay. Hold on. Hold on. My sequence I will have to edit because the dark here was not on the comet is there. Hold on. I will have to change the sequence. So 4 seconds. Okay. The dark is 4 seconds. Save sequence. Okay. Now it should work. Four seconds. And let's hope. Auto color. Auto stretch. It's working. Okay, you see the tail is almost cut. This 12 inch is much harder to balance. I'm not sure if I will have to move the magnets I have. If it doesn't move up and down, it's okay. If it only moves like this, if you see this bar here, hold on. Okay, this bar here at the right, a black bar, it means that it's cutting the comet. It's moving, not the comet itself, but it's moving because the tracking is poor tracking. So that it makes the comet placed here at the right. When the comet moves to the right, or the stars, everything moves to the right. This at the right stays like this. Now it's getting here at the top. It means that it's going to the right and the top. So at that part of the sky, that means that I may have to increase a bit the speed. I don't know. Let's see first how it works. Let's wait for the sharp cap to clean this mess here, all this noise. The color is okay. Okay, let's wait now. It will cut a bit. The Comet Leonard was much more impressive, the tail. I have it here. Look at the Comet Leonard. You see? Very impressive. We did this, I did a live stream also, or two. Now let's see the chat while this is stacking. Okay, I saw you already. Yes. If you have any question for me, you ask and I keep while this is stacking. This is the place, the live streams. It's the best place for you to connect with me, and I provide you information about any doubt that you have. Because in internet, in forums or groups or other things, for me to write, I have to translate sometimes, and for me to write is very hard to explain. And here with the software, everything, I can demonstrate you how the things work better. Yes, it's getting. Let's see the image from yesterday, 2 days ago. With I didn't save the image. Oh yes, but it's processed. It's better because it's processed. This was with the 8-inch here. Beautiful. It's crazy. With the 8-inch, you see the coma here, the green, and here the 12-inch. It's not tracking very well today. Maybe the wind. This was here in our live stream. So just to remember the people that arrived now, we are watching the COMET with this 12-inch Dobsonian over an equatorial platform. You see that it's difficult to balance. The magnets is this purse. Have magnets inside. I have here magnets and stuff that I control. I manage the balance here. As it's pointing up, I have to place this upper in the tube. When it's pointing almost horizontal, I have to place it down here. But sometimes I forgot to check very well that, but it's tracking. When it's cutting like this, it's cutting now at the left also here, and it's cutting at the bottom. It's because it's well aligned, but it's the platform. The platform has these errors. I will show you the mess. Look, the drift. You see, it's always like this. In circles, 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 and of course the stars move a lot. Even with 4 second exposures, they move. Olá, Carlos, boa noite. From Portugal. Let me see the filter. It's working more or less. 4.5 and on average 393. It's around 4 and a bit. It's not bad. It's not bad. I think I have it focused. A bit of elongation, but almost imperceptible in the stars. That will always happen with my equatorial platform. Let me check the histogram here to see if we can improve the image. I'm moving this bar. I'm moving out of the peak. Usually we place at the peak, but sometimes we cut a bit of the background like this. Then when along the stacking, when the software managed to clean this noise, we can try again to place it in the previous position at the peak. You see, but now I will move here because this is all about watching EAA. I will move here to the right a bit to have a better image. And now the mid-level, let me see if I can push a bit to the left. No, if I I push too much, it will introduce more noise. So I will leave it like this here. I will not touch the white level. Usually we don't have to touch there. And I will wait a bit. Let me see how many minutes. 7 minutes stacked, 5 frames ignored. It's usual. It's normal in the 12-inch Dobsonian. It's much more difficult to manage the balance because it's heavy. Anything, a bit of wind, it shakes. While the 8-inch, no. The 8-inch is... That's why when it's windy, I will place always the 8-inch. Hello, Epicrom. From Australia. Beautiful country and region. It's getting better now. Let me see the image without processing to compare the 8-inch image, but without processing. I think we were stacking much more time. Live stream. 500 frames. We have 130. This is with 225 2 days ago. You see the noise here, it was the same. Let's see the difference. 225, it's the double, it doubles what we have now here. I think with the 8-inch we had the lack of the scene being a bit better without moon. Almost no moon, if any. Today we still have some brightness of the moon that scatter, and I'm seeing this you probably can't see. This noise here. Yes, I had to make this today because from now these nights will be much more harder to catch. Let me control the color. Let me push a bit. Sometimes the histogram also, this peak moves a bit to the left without me doing nothing. And we have to adjust. During the live stack we adjust. But you see, I'm not always like this because I'm in a live stream. But when I'm alone, I'm enjoying this. We just have these little tweaks. They are always the same to do. And we are still enjoying the image. We go back to the histogram. We do a little tweak here and there. Then we confirm here if the frames are doing fine. They are, more or less. And that's it. Basically is what I see. I forgot to do the enhancement. Here in the enhancement tab I always do this. The bilateral filter I always do. I always use because I tried in every object and it works always fine. The unsharp, no, because it will blow here the core. I will show you again. You see? It will blow. And we prefer not to use it in this object. In other objects it's very nice. It introduces a bit of noise, of grainy, some grains on the image if the live stack is not. It's still in the beginning. It will mess a bit with the image, but after a while it will sharper. It will get the image much sharper and brighter. Also the stars get brighter with this unsharp mark. unsharp mask. Look at the stars. With unsharp mask, look only at the stars. Without, they get softer. So it's a nice feature. Let me recheck the histogram because it's like this, getting a bit more black in the background, and to enhance. Here I see the green, the coma here very well, and you can see also it's moving fast. Look. Look, it's moving fast, look. You see here? It moves from here to here already. That's why I don't use more than 4 seconds, and even 4 seconds in the globular clusters the same. In the globular clusters we use short exposure. Usually 2 seconds it's for me what works better, and the stars get brighter and don't get elongated, nothing. Well, here with this filter, the full width of maximum here, I have the threshold at 5, so everything that passes 5, if the wind come and mess with the telescope like this, 504, and it cuts. It will not accept this frame. Okay. I have to change the name. It's not PANSTARRS. PANSTARRS, it's I want to show you. Let me just... Carlos. I already ordered the ZW0224. I will receive it next week. Fine. Remember that with the ZW0224 you should have you should use an infrared filter, cut filter. IR UV, it's fine, and the field of view it's much smaller. If you can manage later to use the trick I use with a push to, you will not have problems. That's why I don't use so much here in the live streams this camera, the 224. Not because I don't like it. It's I take more time to center the object. And I'm in a live stream, I don't want to waste your time with that long centering. Of the object. No. Many Portuguese today. Greetings from Litoral Oeste, Portugal. Onde está sempre where is always cloudy. Yes, he lives on the west side. It's the ocean, the Atlantic Ocean, but at the north, it's and even at the south, all the face to the ocean, to the Atlantic Ocean, it's like that. So the comment, it's something interesting for people that don't know. It's the let me show you why it's called PANSTARRS. Probably you know, but I didn't, and many people don't. So where is? Astronomers first spotted the comet in 2017 using the PANSTARRS survey instrument in Hawaii. So PANSTARRS come from the instrument that was used, which is here. PANSTARRS means Panoramic Survey Telescope and Rapid Response System. A system for wide-field astronomical imaging developed and operated by the Institute for Astronomy at the University of Hawaii. Incredible. I didn't know that. So that's why that has nothing to be with names or designations. By the way, the designation is C because it's non-periodic. It's moving a lot. Look. Moved from here at the beginning of the live stack to here. It's here now. The guy is moving. I wanted to catch the when it will be closer to the Earth. It will be, I think, in the 14th of this month, but it will be the moon, I think. Let me check. Yes, it will be. It will be for sure. Let me check the 14. Let me check at this time. This stellarium. 14. Wow. 13, 14. It will be here. 13. It will be here. The full moon, or almost, I think. It will be so bright that I don't know. And the position of the comet. Where is the moon? And on the 14. Where is the moon? Where is the moon? Moon. Yes, it's already there. Let me see. We started this live stream at this hour. Maybe. Of Yokujit's here. Yes, it will be okay. It will be here rising, but I think it will be okay. Let's see. Now it's cutting here. It's the tracking. And we will adjust the image. 18 minutes already. 18 minutes. And we will see. It's too much green. No. Okay. This is the color. This is the color, like yesterday, like 2 days ago. And now, let me see. Like this. It's huge. You see, with the 8-inch, it's not. I think it's not so magnified. Let me see. The 8-inch. I have it here. Okay. The 8-inch. This was the 8-inch image. With more or less this number of frames, yes. We did more a live stack a longer live stack. And you can see it's the 12-inch, so it's more magnifying also. And if we zoom, it's very similar. Even with the moon, the 12-inch has the power of boosting here the coma and all this green area here. But this one is brighter. It's because of the moon for sure. I think. Because yesterday I didn't watch this comet, but I was watching another. Was the Iris Nebula, because I was also anxious to watch the Iris. Because of that, I said to you, I had a LED light, a street LED light there, messing every day, every night. And now that I don't have, it was the first object that came to my mind to watch. I got to see the Iris Nebula without that glow or all glow there messing with the image, and it's much better. It's impressive. The image I took yesterday, it was the best image I ever had of the Iris Nebula. It's not tracking. No, it's failing. Where is it? I mean, look at this. It's impressive. This image with a Dobsonian. To say that the Dobsonian is not for imaging, it's cutting and it's failing. The look, loads of reds. I knew it. The Comet, now you see the bar, the black bar. The bigger bar, it's down. The Comet should be more or less here. The distance of the bar from the Comet, it will be the distance the Comet in reality now is. You will see now. I changed the view for individual frames. You see? Here. It's here. You can't see, but I can't boost. But one gets used to this. As I almost every night that I can, I go outside with my Dobsonian, one or another. Now let's stop this. I will. It's not very nice today, but I will save. It can't stand much more time. And it's cut here. I like more the session. Well, this is okay also. It's a bit more yellowish. Let me adjust this. But the yellow tint usually, like we had on Leonard, it was because of the I think it's the sun or something. The effect of the sun. And now with the moon, all of this. Let me check here. Ratings. The size of the sensor ZW0294 is very good for deep sky. Very good. Very, very good. I love it. And it's the best price and quality combination for me. For our setups, for the Dobsonians. It's a good camera because of the size of the pixel, everything. It's very nice. Find the objects. Now I will change this to the regular view. I lost it here. Hold on. And 294. And I think we have time to watch one more object. It's getting hot here. me check. Let's see. So this is on time. The moon is almost disappearing, and we can see. Let me see. The moon is there. We have lots of things to see. That's why I usually watch only one object in the live streams, but these days with so many objects, let me see. Do you want to see what? The lagoon, the Trifid, the Swan Nebula, the Eagle again. The Veil Nebula is beautiful. I can watch it just in an area. I can't watch everything, of course. The Dumbbell is beautiful. Do you want to see the Dumbbell? The Cocoon is beautiful. We can see anything. Let me see the Dumbbell. It's against the moon. The position is 52. Okay. We'll watch the Dumbbell. Control 1. So what I will do is again the square 1, 2, 3 stars, and here an imaginary 4th star which makes a rectangle, and I will place the tail rod of the telescope more or less here, and then we will have the help of the push to system, the free one. So let's point the telescope. Check out NGC 6888. Okay, let me see. Let me see what NGC you are talking about. NGC 6888. The crescent. Okay, I can do the crescent. The crescent nebula, I will not use the... I can use the magnification, the trick. But if I don't use, you see, because it's also huge, it will be more sharper. Yes, I will not use. It will stay... It will fit better on the screen. For the live stream, I think. I know the crescent. And it's a position of the sky that for me it's not the best one to track. The platform... Alexa, para. Sorry. The platform in certain parts of the sky works better, and in other parts of the sky it's harder to manage. This part is not so good because of the speed. You will see it will tend to go up and down, up and down, up and down. It's funny. Okay, let's see the crescent nebula. First, Control 1, my push to system for free. Love it. Where is it, the pointer? Come on. Go there. Crescent. Okay, now I will point the telescope. Let's restart. This one is easy. We have Cygnus. We have the middle star, the central star of Cygnus. We just place a tail and a bit to the right, and it will pop on the screen. I will use, yes, the mini histogram trick, because this is needed for this nebula. This pan here. It's full of stars, that region. Okay, let's find I've been imaging it lately. Ah, okay. It's nice. Astrophotography. You're doing night after night? We'll catch it now. Let's use the plate solve. I think I'm near it, but the lazy way. Plate solve. Solving. When the bar turns green, Alexa, para. I'm sorry, my Alexa is getting crazy. Something I said. Oh, I have this. It's not working. What's happening here? Let's see again Stellaring. I will reset Stellaring. I don't know if when I change the dates, I don't know. I have no idea. So I will reopen. You start a line. Yes, I definitely. I think you are an astrophotographer. Oh, it's there, the crescent. I think it's here at the left. But let me see the push to why it's not. It worked and now. Why? One, it's there. It's not the problem of Stellarium. Maybe this too much. I like to understand when the things fail. I like to understand why. So the next time I can avoid it. I just lower a bit the histogram, the mini histogram. Now it worked. Or maybe it was the resetting thing. As I was changing the dates to see the moon. Yeah, it will be that. We are always learning. When I was star hopping, you saw that cluster. I thought it was the cluster, and I moved the telescope up, but I forgot to move it left. Yes, it's the crescent is there. Look, I was here, and this is my camera. The telescope is pointing here, so I'm catching a bit of the crescent nebula. It's here. It's here. I saw something there. I will center it. I will push this more for you to see while I center. It's a difficult zone to capture. Loads of stars and... And now I was struggling. It was centered, but I want it a bit more up, because when I open the histogram, now here I can't use, you see the stars, all the stars moving. I can't use long exposures. Long. They're not long. Okay, 25 nexus, you see I have a sequence. 25 of temperature with a nexus, live stacking 8 seconds at 350 gain. Without a trick. With a full sensor. And it does the job for me. But 8 seconds I think it will be too much for this area. It will reject for sure. Look at the stars. It's when it's not wind at all. Look, you see how I struggle? This is not so easy in my videos because it's all edited. And even me speaking, I translate some words that I don't know. The videos are very beautiful, but here at the live streams is where you can see how I struggle with the different things, the balance, the problems with the software. This now, I probably have to... I think it's balanced now. No, a good frame. Okay. I was clearing all the frames that were appearing. I was not liking it. And clearing here at this button. Clear. Resetting until this frame appear. And I like this frame, all the stars. Very nice, you see. And now I go to the histogram. First the color. But it's rejecting a lot of frames. Well, we will try. First the color and now bam. And it appears. Look, with one frame. This is only one frame of 8 seconds. It's not aligning, you see. It's not aligning because I will show you. Let me just... I will do the 4 seconds. It's not identifying anything, I don't know. Sometimes it gets crazy, the software also. When it's like this, Not green, neither green, neither red. You know what? Close camera, close sharp cap, close this also, and reopen it. Look, Uranus. Reopen. Wait a few seconds. This is what I do when I struggle, and sometimes I take off and the USB cable and reconnect it. Now sequence, open the camera. Let's see what's happening. It's there, okay, sequencer. I will try the 4 seconds, I have it here. 25 temperature, 4 seconds, 300. I use always the same gain. For me it's the gain for this sky. It doesn't mean... Why? I will check the telescope again. Maybe the focus. Yes, I will refocus this. You see, another struggle. I will refocus. Okay, I will... Hold on. It's not focusing. There you go. There you go to reset everything, Gary. Okay, let me check what I missed here. Oh, I'm glad you're entering this world. This is a beautiful world, full of beautiful things and positivity. I live stack when I image with sharp caps, so electronic assisted astronomy is very familiar to me. Okay, good. Good, good. You're on the right place. Yeah, something happened here. Thank you. Thank you all for helping. When I live stack, if my subs don't have enough stars in them for the sharp cap to count, it keeps rejecting frames. Also that. It probably was that, but because of the autofocus I have, you see, I will refocus with you for you to see. See? This is autofocus. Look at the stars. Look, they look like ice. Look. Now, fortunately for the 12-inch, I have this this remote I installed, and I can focus from here. No, the wrong way. You see why I like to start the camera with 2-second exposures? Because like that, I think they are 2 seconds. I can focus better. No, 4 seconds. I didn't start. I start the camera with 2 seconds, it's better for focusing, and again at the higher value. It's 550. I will restart. You see? It's much better. You see? Much brighter, and for focusing, it's not yet. And I just have to wait a bit while I'm moving. I have different speeds here, but as I have poor tracking, I have to wait 2 seconds and then adjust, 2 seconds and then adjust. It's what I'm doing. And I usually don't zoom. I don't need to zoom this so much. I'm zooming because of you, for you to see. Okay, now it's fine. You see, when it moves, because of the arrows, it seems like it's focused, but then it's out of focus. But it is. No, it's fine. I have to wait a bit to see if when the image stabilizes. This is the problem with the poor tracking. If it keeps... I think I'm losing the connection again. This is awful today. I will find let me shut down the browser. We'll close everything. Okay. The connection is awful. Now it's focused. Now I will try to capture the nebula. I don't know if you are watching. I think I lost the connection. No. Okay. I'll shut down this. I will try to capture the nebula again. Hold on. Plate solve. Plate solve. And let's see. Test. Yes. Let's see if it's almost there. I tend to go down. It's almost there, a bit up and left. Okay. And I think I will disconnect Stellarium for now. Okay, up and left. It's there. Now let's try it again. 25, 4 seconds, 4 seconds. I will not risk now. Yes. You see, when it's a bit out of focus, it was out of... it's not doing good stars. I will lower this to 5, the threshold here. Yes, to 5, because it's when it goes more than 5, when it passes 5, look, it's awful. This is the balance. It's the balance. It's in the hard part of the sky, and also with too much up, pointing too much up. My 12-inch, it's much harder to balance. But now it's working. Okay. Auto color, auto stretch. What I did here? I used the trick and I didn't want to use the trick. It's happening? I know I didn't. It's working with a full resolution. No, it's with a trick. I don't want this. I did something wrong here.
Lo siento, no he encontrado ningún grupo o dispositivo llamado bombilla.
Come on, Alexa. Now it's okay, but it's not working in the dark. The dark. Subtract dark. It smells like some bug here on sharp cap. Again the dark, not finding the dark. I have the dark all applied. Auto color, auto stretch. Now it's working fine. I was blaming the telescope, but maybe the problem was not only the telescope. Now, let's push a bit this. Where's the music? No. I have something working in the background, maybe. Let me check. Firefox, okay. It's the connection. My connection, it's not so good, maybe. You know, it's summer here and loads of people. It's here. Yes. Well, let me check the chat. While this is, let me just boost a bit. It fits better on the camera. If I boost a bit. Rejecting some frames, not a problem. Let me check. All good, okay, thank you. Well, keeps rejecting frames, I saw this already. Yes, NGC 6888. Yes, this is how I focus my Newtonian astrograph. Oh, beautiful, an astrograph. It's nice to use the image of the spider veins. It beats using a button of mass like with a refractor. I think so. I think the button of masks are good for other kind of telescopes to help them. But here, with the Newtonians, I don't need it. And it's a nozzle, it's so big. You imagine a button of mast for the 12-inch Dobsonian. Huge. And having it around. As far as I understand, if you are doing purely visual observations, I don't think you need an equatorial at all. Yes. That said, if the DIY equatorial platform is done well enough, it could work. Even that it's not well enough. I think that even with poor tracking, you see that my tracking is not very good. It's getting down now. So if it's getting down and this nebula is going up in the sky, it's going like this. So if it's down, it means that I have to lower the speed. Let me just lower a bit the speed. It's just a millimeter. Check here. Let me check here first. The drift. Yes, it's getting down. Yeah, confirmed. Okay. For equatorial platform owners, usually in certain parts of the sky, and especially with an heavy telescope like this 12-inch Dobsonian, we sometimes have to adjust the speed just a bit. It's just a millimeter. I had it at between. I usually use between 6 and 7. It's my speed, and was almost 7, and I just a millimeter. Between 6 and 7, if I divide in 10 parts, each part of 10 is what I move. It's like a millimeter just. And it's enough. It will not adjust the speed immediately. You see the frames continue to go down. But slowly it will stop that movement, and it will start probably to go up again or stabilize if I spot on the speed I need. When I spot on, it solve all the problems. Now let's decrease the green. You see a greenish tint. This is the vignetting, this circle here, because I'm using all the sensor. It's normal to have in this camera. And what I do, the trick to overcome this, because I don't use flats. If I use flats, I could get rid of this, but it's not worth it because the work we have. If I could use the flats, every day is the same, but I have to do regularly or at least every session. So I prefer to do like this. I decrease the green, because it's the color that is too much on the screen. First I adjust the color. I will zoom to see better the peak of the histogram here. Yes, now it's better. Okay, green, blue and red. Okay, and now I move it to the right a bit, you see? Well, why I don't use flats. Okay, let's take off check the zoom. I move a bit to the right of the peak, and that's it. And it's still here, the vignetting, you can see it still here, but much more softer. And after a while of the live stacking, usually 10 minutes, maybe more deeper in the process, it will soften even more, and we readjust there. I like to do this. I don't like to do processing. It's boring for me. But this I don't. I like. Look, the mid level. This bar. It's only 2 bars to adjust. I push a bit to the right and look at the vignetting disappearing. You see? Enough. Because if I push too much, it will cut details of the object. It's a bit of a work we have to do here. And it takes brightness, but then I trust my telescope, and after a while, I readjust and I try again to push. Now let's push a bit this black level to the left. You see? It's okay. Okay. Until I see the threshold where it starts appearing again, the vignetting, this circle here. You see that is much softer. the tendency is to, along the stack, is to getting better. So I leave it like this, almost done, not to cut a lot of the image details, and then it will getting softer, you will see. Now we have 4 minutes only. Look how hard it is comparing with the 8-inch. With the 8-inch I have 0 frames ignored and like that. Today with the crescent, okay, it's an hard part of the sky. I have at this moment 71 frames stacked of 4 seconds and 66 ignored. That's the balance I use. I usually use the filter to cut frames, bad frames, but not just to reach half and half, 50-50 more or less. I don't want to have, for instance, 50 good frames and 100 or 200 bad frames rejected, because that means that I have to wait a lot for the image to build. So this is the balance I use, managing the full width half maximum. Here you see green, 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 red, 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 green, red, red, red. It cuts more or less this. If I increase the threshold here, it will accept more frames. It will be more green, but not so good frames, and the stars may get elongated. Like this, I get a balance. The trade-off is in 10 minutes stacking, I lose 20 minutes. I spend 20 minutes because 10 minutes for the good frames and 10 minutes for the bad frames. So we more or less manage that at the beginning. We see if you want to stay, okay, I like this object very much, I want to stay here more or less 50 minutes, let's say, watching it. And you manage in a way that you will get 7 minutes of good frames and 7 minutes of bad frames to get the 50 minutes time. Know what I mean? It's what I do when I have trouble with tracking. And this is nothing to do with polar alignment. Nothing to do with this is polar aligned. People oftentimes make loads of confusion. There's loads of people out there that don't know nothing about Dobsonians. They know about other things, other telescopes, and they mix the things, and the Dobsonian with an equatorial platform works in a different way. There are tricks and things that we do with this setup. It's easier, but it has its own characteristics different from the others, like this one. So this already. Yes, and it will look better. We have only 5 minutes stacking. It's not an easy target, this one. Gary, I'm in the south of Europe, in Algarve, Portugal, near Spain. Yes, it is. 6888. Nakamura, I was thinking, you are talking to SMA, about my 8-inch Dob with a 4 million eyepiece. If you observe planets, it's fine, but after like 20 to 30 seconds, the object is out of view. Yeah, it's very good, very good, very good. Actually, I bought the platform, the equatorial platform, with the purpose of visual observation, not imaging. Then I saw that it works so fine that I bought the camera. But the initial purpose was visual observation, because I with my family think like me, and you probably have the same situation. Not only you watch from the telescope, or at least sometimes someone goes with you and you show the telescope. If you are watching, for instance, Saturn, no, you get Saturn in a field of view, and then you call someone, no, come here to watch Saturn. They touch the telescope, that moves, but it will be more or less at the center, even that it's roughly polar aligned. The platform we point to the north more or less, and it works. We don't need. It's another myth. The perfect polar alignment. I don't have perfect. I have good polar alignment, but sometimes I don't, and I take the images. I have a bit more of work managing the speed and the balance, and the work is easier with it polar aligned. But you see, I have it polar aligned now, and I having trouble. Look, rejecting frames. Rejecting. This is the movement. I'm sure. Let me see the drift. Now it's up. You see? I changed the speed a millimeter, and from down it went up. Now I go outside and I will increase the speed again. That's it. And it will go down again. And now readjust here. You see the vignetting. It's getting better and better. Now we push a bit more again until we see a bit of vignetting like this, just a bit here around, and we wait again if it works. And that's another problem with the heavy telescopes over an equatorial platform like this, the regular one. When the platform, in a while, the platform will be pushing the telescope up. Now it was getting down, and then it will be up. That's why it's so important, the balance. And when it will go up, it will demand more speed, more traction, and sometimes it's a problem. Let me see. I don't know. I'm too lazy. I'm lazy for certain things. I don't know. The flats, the dark side don't. It doesn't matter because I have all the library, and usually before big changes, huge changes of temperature, like now, I did flats for the summer with the hot weather nights, because the temperature changes a lot, and I want to match more or less. This dark is about 25 temperature. The camera is now at 25, spot on. I did flats because I knew the hot weather now, and maybe in August. In August, I have to use the. In mid-July, August, I have to use my mini cooler, because if it goes 30 or over 30, above 30 Celsius, I connect the mini cooler and it will lower 5 degrees. And that's it. My mini cooler is for 5 degrees. Yes, it looks already amazing. Remember, we are watching this live with no post-processing yet. When I post-process this with just a push of a button with Topaz, I don't like to spend time on that. I don't have the patience for that. And it will enhance much more the details and the nebula. And we crop it, it will be like this. This nebula, when it's stacking fine, slowly gets the nebulosity here. The astrophotography guys, which use hours and hours and nights and different nights to capture the objects, they can, if they do a good work, they can catch all these nebulosity here in the middle of within this the arms of this. This is like a circle, no? So it was a supernova. Daniel, bem-vindo, galera. Muito obrigado. Brasil. Brasil é sempre bem-vindo também. Welcome to Brazil. Excellent question, Jello Man. Where do you draw the line between EAA and astrophotography? Excellent and very simple to answer. When I do this, I'm still doing EAA. When I do this, I click here and I click on Save Exactly as Seen. I will take your message for you to see. Here, down here, at the left, at the bottom and left, Save Exactly as Seen. I click, and it will save. You see the green bar? It saved this image. I will show you. I click there. And I have here a snapshot. This is an EAA image. This is an EAA image. Now, if I do this, crop, okay, and I save. This is an EAA image. It's still an EAA image because I only crop. If I do, where it is, if I do this, rotation, it's still a EAA image, because if you think, I didn't enhance, I didn't touch anything, I didn't process anything in the image. From the moment I do this, I click here, for instance, this is not an EAA image anymore. This is astrophotography. This is the line, the post-processment. While you don't post-process anything, it's an EAA image. That's the line, and it's so simple as that. Now, we can talk if astrophotography and if it's art. Well, I don't want to mess around that. But 482 for a 12-inch f5 Dob, I think it's okay. I don't remember. I can 12-inch f5. I can check it here. Hold on. Let's see. I have here the formula, and but I need the data from the camera, the pixel size. So it's the 482. Let's check. So the 482. ZWO 482 or 462? 482. Okay. Pixel size 5.8. So we go here to my formula. This is easy to do. I have it all. We go here. The aperture, it's 12-inch f5. Okay, it's like mine. So a 12-inch has aperture 300 millimeters, focal length 1500. Pixel size, it's the pixel size of the camera, I don't remember anymore. It's the pixel size, I don't remember now. Pixel size 5.8, I place here, 5.8. Sensor to flange distance, this is the distance. This is for the focal reducer. I will not use 0. And 0 spacers. So your arc second per pixel, we don't need a formula. We come here to the table, I was silly. Focal length 150, it's more or less here. Pixel size 4.5, more or less. So you will be oversampling. You will be here on the table. You want to have the pixel here, but you will have also this with these pixels. What you will have to do is one of two, or binning. If you bin 2x2, you will push this here, or and better use a focal reducer. If you use a focal reducer, you will have round. Okay, it's rounded. If you use a focal reducer, let's see the sensor to flange. Sensor to flange. Sensor to flange of your camera. You go to the ZWO website for any camera, you can see that. So the sensor to flange is 6.5. 6.5. Flange to spacers. This one has the... Yes, it has. It has that black 11 millimeters from that black adapter, that black ring that it has. If you use no spacer and a focal reducer, a cheap one of 0.5, just that, near the sensor, you will have 4 millimeters of a spacer. You need an adapter to get a focal reducer, 2-inch focal reducer to the camera. It will measure at least 4 millimeters. With this, when you had 0.8 of arc second per pixel, now you will get 107, which is better for you to image. So I recommend that that camera is okay for you, for your telescope. It fits. Let me see how the stacking goes. I can push now again this to the middle. We have already 12 minutes, and now I can push it much more. You see? Let me see the colors. The red is a bit up. We take a bit of red and a bit of green. Yes. Now it's more balanced, the color. You see, this is focused. We have the spikes okay. It's very nice. Look how the 12-inch in this beats by far the 8-inch or the 6-inch or the 10-inch. I don't know, I don't have it. But it beats, of course, but I don't know the power of the resolution in the same circumstances. Look, the middle of the nebula here, it start more and more to get detail. You see? This is a bit addictive. Most of you, if you do live stack, you know that. But if you are beginner on EAA, this is a bit addictive, because we start watching the detail more and more and more, and we want more. So we tend to go more than. Now it's 12 minutes. Sometimes I'm enjoying so much that I go even not more than half an hour. But sometimes one or another nebula I watch for half an hour. It's a bit crazy, but I'm obsessed with this. What can I do? Okay. Okay. I'm here to share with you. To share with you all the knowledge I have, what I'm doing, the problems, how I overcome. For you that are in EAA, even the experienced guys in EAA can learn from these situations, because sometimes I fail in something and they identify the same situation. Let me see how he does that, and they can learn with me, and me with you also. But with the Dobsonian, it's lots of nights that I pass here with Dobsonians and doing this, and when I want to adjust the spacers and that stuff, I like to experiment and go outside and come and change and compare, and I like that. I can be all the night here, no, but lots of time here doing this. So now it's getting fine, the nebula. It's rejecting a lot of frames. Now it's the platform, it's getting up, where it's the drift graph. You see, now it's getting down again. You see how crazy it is. But now I will not adjust the speed again. I will just save as scene. I think with this image we will have already. No, maybe I will adjust once more. Hold on. I went from the other door to not to pass in front of the telescope. It's easier. Just a bit more stacking until a bit more, some more minutes, because I'm enjoying this central part. And if I was with the 8-inch, no, but with a 12-inch, worth it to push the limits and try to get because this, after this post-processing, I will pass through the denoise, and let's pass the COMET through the denoise. It's my astrophotography is this denoise. Click and that's it. I don't know the future, but I always say that, but I never it doesn't attract me to post-process a lot. Sharp cap. I go to the folder of the capture, today capture. It's with now we have two folders because Here it passes the midnight, so it opens another folder. I have only one image. Okay, it's enough. You see, I do this. I pull the image here. It's not cropped yet, but I crop after this. It's update. I just do this. I don't even touch here. I don't want to push the settings. You see? Like this. Just to clean all this noise. And then I save it. Save image. Save image. And that's it. I don't touch more anymore in the image. For you to see what astrophotography I do. And that's because if I touch now this too much, I can make sometimes with a Photoshop Express. It's free. You will see the image now. I can touch the brightness to correct, because it's just the brightness or the exposure. But I don't like to change the image, the real image. That's why I get lazy, you see? Now I crop. This is astrophotography now. I crop. And I save it. Like this. It cut the save as copy. Now I will save the same folder. Copy. And that's it. See? They have the image. That's my astrophotography. So I enhance a bit just to sometimes just to get it brighter or something. I really don't like to change what I'm seeing. And people from EAA usually, some people like to save all the frames. We are watching with frames. They save all the frames and then they stack outside and process with PixInsight or with Photoshop. But I don't, because I will change then the real image, and people pure EAA, from pure EAA, that's what I think, like me, we like so much to watch this the real image, that we tend to ignore the processing. Besides, the fun of this is what we are having now, watching this building and getting better. I'm watching now more details here, more and more and more. And you'll see when I clean the noise with the noise, it will be fine. I think that the platform may be stopped or something. It's rejecting everything. Now I will save as scene when this happens, the last image. It's already 40 minutes and a half. And we will I will disconnect the platform because I think it's at the end. This is reality. You know what happened to my telescope? I can't show you because I have not the camera outside. The telescope, I went outside, it was not stacking, everything was red. The telescope was like this. You see the importance of the balance with these telescopes. I had it like this, almost at zenith. And then, for some reason, it was not well balanced. I did not make the balance. I did not make the balance, and it was at the moment because it's rotating the platform, it's moving, and at some point the weight of the back made the telescope it placed it on vertical. So this is to show you the importance of the balance, much more than to be precise with the polar alignment. Because without the balance, even with polar alignment, without balance, we get it all over the place. Now let's just process do astrophotography with topaz denoise. I will push this image, this last one. So it's already day 6 here. And let's see what we get from here. I will just do like this. It's updating. I'm sorry. I'm just pull the image. I just pull the image to the software. And then he automatically updates. I use the low light for EAA for my images. It's the filter that work better, you see? It clears all the noise. Like this. And with a 12-inch we can magnify, and using the Nexus we can magnify. But if I use the trick I didn't want to use because of this messing of the tracking. I knew that was going to be bad, the tracking in this part of the sky. But sometimes in the south in certain regions I have a good tracking. The platform behaves well. It's amazing. Updating again for you to see. And then I use the trick. I use just magnified, and it's even more brighter. It's worth to use the trick. Save the image, and we have the image. Tomorrow I place it on the channel. It takes a few seconds. So usually I crop before pushing it to the denoise, but here in the live stream, you see the progress bar here. It's taking. I think my laptop is managing loads of software with the live stream. It messes with the performance of the CPU. Processing. I hope it will not crash. No, finishing. Okay, and that's it. That's my astrophotography. It's done. So welcome. No, thank you for being here. Now it's the time to finish the live stream. I will be streaming probably, if the weather keeps like this, I will be streaming more, maybe on this weekend again, to watch more different objects with you and keep connecting with the sky like this with EAA. Thank you very much for coming, and have a nice rest of the week.